It is my sincere pleasure to introduce Dr. Alian Kasabian for our first RDAR seminar series of the 2023 spring semester. Alian is the director of the Methodology and Evaluation Research Core Facility and is also the Research Data and Security Liaison in the Office of Research and Economic Development here at the University of Nebraska-Lincoln. In both roles, Alian focuses on data management and sharing, protections for research participants, and using accessible language to communicate study findings. Alian is passionate about helping people understand data, and I am very excited that today Alian is going to be talking about considerations in data organization, data de-identification, and data sharing. So with that, I will turn it over to you, Alian. Thank you so much.
Thank you so much for that, Devin. We all know why we're here. For those of you who don't know me, it is pronounced Alian, like the animal. If you're more of a image person, there's that for you. If you're more of a fun fact kind of person, I'm also a Leo, as well as it was my dad's favorite animal. My mom loves a theme, apparently. So here we go. I take no credit. So the focus of today's talk is an overview of various considerations for data sharing. I do want to say that this is more general than specific for the simple reason that substance use research is not monolithic, right? So it varies wildly in terms of how sensitive the data is, what is the risk associated with it. So no matter what the topic is of your research, sensitive topics are always going to need special handling when it comes to data sharing. So Wayback Machine, if you remember the scientific method, right? So this process for how we generate and use data, there are a lot of opportunities for associated data concerns, associated data issues within here, particularly sharing, what we're focusing on today. This does sort of imply that things are a lot less, this graph makes it seem like things are a lot less chaotic than they actually are in the life cycle of data, but squiggles are harder to understand. Something like this may more accurately portray what the life cycle looks like of data. And again, lots of opportunities here where data sharing might be relevant. Before we get into more nitty-gritty, we need to understand that there are different types of data sharing. So one type of data sharing is like you might have for collaboration. So you might be working with someone else at another institution or even another department. And the more sensitive your data is, the more structure that is required for that sharing. But there's also data sharing for open science. And this, that scientific method, it requires replication, but there are a lot of barriers to that process. And open science tries to counter these. So the list here is from the Organization for Economic Cooperation and Development. And we're probably most familiar with this replication and verification of public results reason for open science. But there's other reasons as well. I don't know about you. I have a lot of orphan data sets, and by me, I mean our office. Data that was collected for a purpose, it was used for that purpose, and then it gets shelved. It gets archived internally. It's not shared in the public. There's a lot of reasons for that, but wouldn't it be great if it was available to other people? All right, so hopefully we can reduce duplication of effort. Also, I'm at UNL, University of Nebraska-Lincoln. We are a research-intensive university. We have a lot of resources around doing research. That's not the case for everyone, as well as people outside of academia who have the skills and knowledge to do this. So it would be fantastic if we had more productivity around the data that we're already collecting, not to mention the potential for innovation, right? We know that having additional viewpoints and perspectives on data can be incredibly rich and valuable in terms of advancing our understanding of phenomenon. And of course, we hope that this then results in increased trust in science and support for publicly funded research. Here in the US, part of this is driven by directives from the White House. So in 2013, the White House Office of Science and Technology Policy directed that all agencies with more than $100 million in annual research and development expenditures develop a plan to support increased public access for the results of federally funded research. And they did. The agencies did that. And then about 10 years after, last fall, they pushed a new policy out, a new directive that said, you need to get it out quicker. So the 2013 policy had some loopholes to allow people to wait. And the new policy says, no, you need to get it out as soon as possible. And this is partly informed by the lessons we learned from, if you recall, Operation Warp Speed, right? Now, I don't think most of us are getting Operation Warp Speed money to get data out so quickly, but that is part of, what could we do with all of that open science that was available? So you may be possibly more familiar from what you hear from journals, right? So journals are increasingly requiring that public sharing of data is part of your submission. Some people call this a credibility crisis because there have been so many instances where published results have not been able to be reproduced, remembering back to that scientific method, right? So there have been instances of data misrepresentation and data falsification. A famous example of this that continues to haunt us are the Wakefield studies. So these are studies in 1998 and 2002 that tried to link measles, mumps, and rubella vaccines with autism. And these studies were widely denounced. There were so many issues with the data itself, not to mention some ethical conflicts of interest. And, this still comes up today. But that is not a 20-year-old problem, the problem of the bad research. This is a headline from a couple of weeks ago, right? This is not an old problem, this is a continuing problem. So this is part of, the more eyes we have on the data set, the more people working with it, the more accurate we hope our results are going to be. We're also hearing it from the funders, and recently you might have heard a lot about this because of the new National Institute for Health policy that took effect January 25th of this year. Right, so this new data management and sharing policy, if it's not for all of their grants, but grants that are generating scientific research, and that's the focus. They aren't the only one. National Science Foundation has a data sharing and management policy going back to 2011, so even before the earlier directive. The details vary a little bit by division and directorate and program. So you really have to look and see what their requirements are. The Centers for Disease Control have to require a data management plan if a project is collecting or generating public health data. And that applies not just to grants, but also to contracts and cooperative agreements. I include Department of Justice on here because I know there are some substance use related research in there, but they actually don't have a data sharing agreement plan requirement that I can find. What they do have is a data destruction requirement, which I found amusing. Institutes like SAMHSA, so the Substance Abuse and Mental Health Services Administration, I could not find any reference to that, but that's probably because they tend to fund public service projects as opposed to research generating projects. And obviously, if you're working with private entities or foundations, it's going to vary. If you are not familiar with any of this, this can seem like a big change for substance use research, but there is still this push for it. If you look historically, as like a study in 2019 looked at, study am I looking up, that out of 38 high impact addiction journals, 28 had a data sharing policy requirement from their publisher, although it wasn't required for publication. Other studies who have looked at these and say they reach out to all the people who had, and this wasn't specific to addiction journals, but when they reach out to the people who said that they would share their data, some of those studies found the people who agreed to share their data, that provided their data, was only like 7%. And a study in 2020 found that of 394 addiction-related randomized control trials published between 2013 and 2018, none of them had shared data. But like the National Institute on Drug Use is saying, yes, we should be sharing data from clinical trials. It's not always possible, which I'll talk more about, but know that that is still the drive. Okay. In terms of data sharing, there are a lot of potential considerations. So this isn't going to be a deep dive because there are so many and we have limited time. And for the sake of simplicity, we're going to pretend that this is a linear process when it very much is not. So at the planning stage, you need to be considering your options and you need to be thinking long-term. What you can do with your data is going to depend a lot on decisions you've made even before you apply for funding, if that's part of your process. So for example, with the new NIH policy, what is included in your data management and sharing plan is considered part of the terms and conditions of the grant. And it is part of your annual review process, and any changes in the timeline, the scientific direction, or changing of a data repository have to have prior approval before that can go through. If you are collecting human data, which I'm assuming most of you are probably more in that camp than another, you have to, assuming you're using informed consent, please be using informed consent, you're bound by what you're telling your respondents are going to do with your data, because that's what they're agreeing to, right? And you also need to consider things like outside entities that might have an interest in your data. And here I'm talking about like collaborators, partners. For example, if you are working with a tribal entity, you need to know that you're going to have to go through an additional approval process because tribes are trying to take care of their people, right? Tribal sovereignty. You may need entirely separate review processes. And if you want to share your data, they may collaborate and say no. You know, they may come back and say that this is too risky for them. You also need to be aware that requirements may change over the course of your project. In cases like the NIH policy, it's not retroactive. The policy doesn't apply to awards that were already in place on January 25th, 2023. However, and things like no cost extensions and things like that, those aren't impacted by a change like that. However, like a competitive renewal is. So just because the project continues, if you need additional funding, in this example, the NIH example, you would have to add this DMP plan. So in terms of data sharing, it matters who owns the data. If you work at an institution like UNL, more than likely, your university does. And part of this is because the university is acting as a data steward, right? They're certifying to funders that they are going to watch over the data for you. Within the Nebraska University system, this is governed by Executive Memo 41, which is the policy on research data and security. You can read the section here. Student data is a little bit different. So it depends on how under what circumstances the student obtained the data, that they're working with the data. And you can easily find this policy, or I can talk more about it later if you're interested. You don't have to share everything. So when you're planning for all the things, you don't have to try and keep like your lab notebooks cleaned up or preliminary analyses. Those aren't the types of things that they're looking for in terms of data sharing. They're looking for all scientific data that is related to your scientific objectives. So that includes significant findings as well as null findings. So overall findings related to your scientific objectives. Okay. And this also includes the metadata, which are things like your code books, your data collection instruments, all that documentation so that people know what you're working with. It does not mean all data collected. So data sets that are shared as part of a data sharing policy are usually, hopefully, cleaned up. Pieces are taken out, pieces are modified, which I'll talk more about. So once you start getting into collecting your data and everything, you might have to deal with data moving as well as keeping track of your decision making. Common scenarios where data might be in transit, as it were, are if a PI or another key personnel, and I mean that generally, not in a grant specific sort of way, if they change institutions. So some grants are tied to an individual, like for under an NSF example, like a career grant that's tied to the person, whereas larger grants and even smaller grants are sometimes they stay at the institution regardless of where the PI goes. And in that case, or in the case of sharing data with collaborators, at another institution, or for highly sensitive data, even someone at the desk next to you, you might have to go through the structured processes for data sharing and transfer. At minimum, this usually involves either a data use agreement or a data transfer agreement. If your project has anything involving intellectual property rights, you're probably going to have to deal with a material transfer agreement. All of these are going to be part of the notification, which wherever the data is going, the research oversight body at that institution has to be aware of it. They have to know about it, and they have to agree to any required restrictions that are attached to that data. And in some cases, you may have to get permission from the funders to move the data. You don't necessarily have free reign. It is incredibly important that everyone who is using your data have the same understanding of what is in that data set. So ideally, whoever is writing, if they are using your data, even if it's independent of you, they should be able to write a really solid methodology section based on the metadata the same way you would. So, and when you go to share that in a repository of some kind, if shared publicly, however that is, you need to follow whatever the rules are for that repository. A common repository that people are familiar with is ICPSR, or the Inter-University Consortium for Political and Social Research. This is a data repository, and they use something called XML, or Extensible Markup Language. And XML is a way to tag the documentation so that it's easily retrievable and repurposable over the course of the data life cycle. There's a very deep rabbit hole you can go down to learn more about XML or different types of markup languages. But the reality is you don't have to if you don't want to. There's an entire field of study out there on how to deal with data collections and curation of data, and the librarians want to help you. So here at UNL, there is a data research or research data librarian team. They can help you with their metadata. They can help you with archiving needs. They probably aren't going to be able to do it for you, but they can assist and they can provide direction. And I'll point you to some resources about that later. If you're going, okay, metadata, I kind of get it. Here are some examples of different types of metadata that may or may not apply to you. Some things you might expect, such as, your interview guides, what was the study purpose, where was it at? But there's other things here that you may not have thought of. So this list is from ICPSR. You can go check that out if you want. But you will need to document as much as possible around your data process. Okay, I've been in a de-identification whirlpool this week, so I'll try not to get too far off track. What do we mean with de-identification? We mean making it so that a data set is not a case in a data set cannot be individually identified. And this is going to be highly contextual, depending on who it is, the population that you are talking about. And the risk is dependent on many, many things. So in 2000, a researcher named LaTanya Sweeney did some research, well, she reported on some research using the 1990 census data, and using just 3 variables, zip code, sex, and date of birth. She thought it was likely that 87% of the US population could be uniquely identified with just those 3 variables. Some people have replicated this and they don't normally come up with as high of a number, but all the articles that I've read have it over 50%. So at least half. And again, these are estimates, but still significant. In 2019, a researcher named Luc Rocher, which I may be mispronouncing, and colleagues reported that 99.98% of Americans could be correctly re-identified in a data set that had 15 demographic attributes, such the same 3 as LaTanya Sweeney looked at, but other things like marital status and what time they leave for work and things like that. The Rocher study, which was published in Nature, led to a slew of headlines around the lie of anonymous data. And there are a lot of issues with it, although many of the examples that they point to in some of these articles were not truly anonymized. There were issues, but still, it is a concern. So when we're talking about human data, we're most often talking about PII, or in the cases of health research, it might be PHI, protected health information. So these are things that would help us identify individual cases in a data set. So what's listed here are mostly what we call direct identifiers. So that piece on its own would help us find that person. Some of them are a little contentious, like IP addresses. Is this something that you could figure out on your own without additional data sets? These things are well known as being issues. The things that are more challenging are the indirect identifiers, or what are sometimes called quasi-identifiers. So it's when these things get combined that we run into problems. So essentially, any additional information we have in a data set that reduces the number of possible people we could be talking about increases the privacy threat, basically. So I was just looking up some Nebraska demographics, and I was like, oh, how low can I get on some of these? And for example, US Census data, American Community Survey, summary tables, I found out in Scottsbluff County, not city, but Scottsbluff County, there are 8 Black men with a 4-year degree or higher. So that's 4 variables, right? That's place, race, sex, and education. The context matters though, because Scottsbluff County is not only 92% white, it's only 1.2% Black. So in determining what the risk is to include these variables in your data set, you need to understand what are the population characteristics of the places in your data set, like who this would reflect, right? Our biggest issue is normally geographic indicators. We also have some special attention we need to pay to medical data and educational data. So under certain circumstances, medical data and educational data may be regulated by federal law, such as HIPAA or FERPA. And in these cases, this is for data that was collected for other purposes. They were collected purposes outside of research. So they're collected for the business of healthcare and the business of education. And it matters who's collecting the data, that's part of it. But also, was there informed consent given to use your data for research? If you have first person consent, so even just like walking up to someone on the street and asking them what their blood pressure is or what grade they got in school or something, and they tell you, that does not fall under HIPAA or FERPA. Having informed consent, also not part of HIPAA or FERPA. But you need to keep in mind where your data is coming from, and that in these cases, if you are working with HIPAA or FERPA data, you are going to have to take more steps to make sure that you are in compliance with the federal law. Also, I don't have a slide on this here, but if you have anything to do with data around the European Union, there's something called the GDPR, which is a lot more strict than American laws around data privacy and sharing. So coming back to de-identification, our goal is to de-identify to the greatest extent while maintaining scientific utility. That phrase is very, very important. So that scientific utility part, and it's going to basically define what the risk is going to be and what your options are for data sharing. This is a lot easier for quantitative data versus qualitative data. So just keep that in mind. And most of the examples I have here for de-identification are focused on quantitative methods. But you also need to think about the fact that this doesn't only apply to human data. I'm sure you can think of some examples where knowing where a valuable resource is or patterns of movement or access might be a risk for things that aren't about persons. So briefly, some common de-identification techniques include generalizing or aggregating, or sometimes I say collapsing up. So for example, taking someone's date of birth, changing that into a date or an age, and then collapsing that into some sort of category, a bracket usually. So here in Nebraska, 19 to 24-year-olds, right, for the young adults. Then of course, masking, it covers a whole range of different ways that small changes are made to the data set to make it so that individual cases do not match actual persons in the world. One example of this is called field swapping. And this would be like, for example, if this level of detail, like age 52 and age 56, that kind of difference wouldn't impact your scientific utility, you could swap them. And you would need to do this over more than one variable, but then that data would not, a single line of data would not point to the individual who provided it. And then of course, you can just remove data. You can suppress it. If you are statistically savvy, in terms of using analytics and things, you can impute data. So imputation is a way to replace missing values in a data set. There are many methods of this. You can also artificially create missing values. So that would be randomly removing some data and imputing data, running imputation methods. And then you'd have to do a lot of checking and all that to make sure that it doesn't mess up all your standard errors. But it is an option. Synthetic data is pretty divisive, it seems like. So synthetic data is where you take real data, but then you put it through a machine learning process and it spits out a data set that is not supposed to be similar, but not identical. So it shouldn't match to real people in the world. So then theoretically, you should be able to share it publicly and it wouldn't matter that it includes all these additional demographics and things. Now, the big unknowns that we have are what other data is available. Right? So some things are well known, like voter registration information. Most commonly that's going to include your name, your address, your date of birth, your party affiliation, your phone number, and your email address. But we know our data is constantly being bought and sold all over the place. And there are vendors who that is their entire job, right? Is trying to collect as much information as possible. In 2017, this company Alteryx, I'm not sure if I'm pronouncing it correctly, they got into hot water and they provide marketing and analytics services. They had purchased some data, some de-identified, I'm going to use air quotes there, de-identified data from Experian, the credit company, and I don't know what else they do, but, and that data set had 248 attributes per household for 120 million Americans. Like I knew it was going to be a lot, but 248. So one of the things with the identification are you make reasonable efforts. So making sure that whatever it is you're sharing can't be matched to voter records, that's a reasonable effort. Trying to match 204, avoid matching 248 attributes, which may or may not be correct, maybe not considered a reasonable ask. I went to their website earlier this week and to see what would it cost to buy some of that data. And it looks like, I'm not entirely sure, it looks like for a single user, the data package consumer would cost around $34,000. So a little bit beyond most people's pocketbooks, I think. But just something to keep in mind. We don't know what other data is out there. So you do the best you can. And there's various methods you can use to try and account for that. The other thing that we need to keep an eye on, particularly moving forward, are advances in technology. So artificial intelligence and, such as machine learning can do things that we can't. They can match across domains that we can't conceptually do as an individual in a reasonable amount of time. But they're doing it, not to a level that it's I would say, great risk right now, but it is something we need to watch for in the future. So then you've collected your data, you've thought about your de-identification, maybe your data set you think is ready to go. How do you even share it? Well, you need to think about what level of risk you have, because that's going to determine part of where you share things. So that disclosure risk, not all data, remember back to scientific utility, sometimes our analyses require, whatever our scientific objectives were, they require more information than we can safely remove or hide, right? And like NIH, they know that, they understand that. So the expectation is not that everyone is going to have open data, publicly available data, with no access barriers. Like that is not a realistic ask, and they know that. So you want to make it the goal is to make it as accessible as possible while still protecting the people involved and what other considerations there are, right? And there's a lot of potential considerations. So in a public data set, there should be no access barrier. So you going to, downloading tables from the census or something, that's going to be open. But a lot of times people describe ICPSR as open, and you have to sign off, if I remember correctly, on their terms and conditions, which include things like saying you're not going to try and re-identify the data or share it without permission, right? So there's varying levels. I feel a little bit of nuance in terms of open access. At the far end, then there's closed data that is too risky for it to be shared at all. In between those, there's a wide range of possibilities in the restricted use section. The restricted use section can vary from as simple as a data use agreement like ICPSR might use, where you say, oh yeah, I'm not going to re-identify, I'm not going to share it without permission, to highly restricted data that you can still get to, but it takes a lot of hoops and maybe you can only access it in certain places, right? And then in addition to that, there's, just so you're aware of it, there are also data embargoes where data is treated as closed until a predetermined date. That was part of that 2013 directive. Embargoes were allowed. I believe the 2022 directive from the White House was removing that. So closed until it is released. Okay, so I'm going to go through, your data could also potentially have different levels of access. So the NSDA, that's what we call this, is a survey of the US civilian population age 12 and up, and I quote, is the leading source of statistical information on the use of illicit drugs, alcohol, and tobacco and mental health issues in the United States. This data is collected by the Substance Abuse and Mental Health Services Administration, and they essentially have 3 levels of data access. Pardon me. Their public use data set that you can just go and download has no geographic identifiers whatsoever. Many of their demographics have been aggregated, and you have fewer options than you would in their other methods, other ways to access. They also have a data portal. And so this is just what you would think. It's on their website. You can go in and select which variables you want to look at, and it'll give you some crosstabs and things like that. What they're going to show you, the only things it will show you, are things that have already been pre-approved for disclosure risk. And again, geography is a pretty big problem. So how large the population is that the data is coming from has a huge impact on this. So coming from Nebraska, you go in there, there's not a lot of options at the geographic level for Nebraska. However, if you look up California or New York or Texas, there's going to be a lot more options in terms of both just what you can see at the state level, as well as more local areas, more like cities, towns. Then there is the restricted data. And this requires a formal process. You have to submit a proposal. By default, their restricted data set does not include geographic variables. You can request them, but you have to justify it. Now, you can't use this data set once you get access to it. They don't give you a data set. You have to access it at certain designated places. Sometimes called restricted data centers. Here at UNL, we have one. They changed the name. It's a little bit long. Central Plains Federal Statistical Research Data Center, and it is located in the Whittier Building or the Prem S. Paul Research Center at Whittier School, if you prefer. And what happens is you get approved for all of this, and you would go to your RDC and you would work on site. And then when you're done, then you submit your results back to whatever entity, and then they go through a disclosure review process. And then you get to wait until they release it. And they do have specific rules about what can be shared, so you're not wasting your time, like sample sizes and the number of people included in whatever estimate you're looking at. The RDC here does not currently host NSDA data, but it could. It is set up to do so. They have several census data sets and ARC data sets, which is health related. But the contract for that includes things like site inspections and annual confidentiality training, and there's just a lot more hoops for that. So then you go through all of that and you like, okay, I found a place for it. Oh, and I should say, there are repositories for, like, NIH has over 100. I should have looked before this. They have a list of repositories that are approved, and they would actually prefer that you use one of those. And so those help offset the costs. So the costs are reduced because they are funded through partially, but there are still costs, at least in terms of human time. So the type of data you have is going to matter a lot, both in your own time and whether or not there are what options you have, and significant costs, potentially significant costs. If your data is something that can be stored on an Excel spreadsheet and also analyzed that way, you have a lot more options than someone who, say, has image data that is then linked to other sources of data and maybe requires some very specialized software to analyze. So those two ends are going to impact, where you are in that continuum. It's going to impact what your options are. Some of the more intensive types are covered under NIH repositories, and that list is available through the NIH data management and sharing page, which I'll show you more about in a second. So the costs for archiving itself, as well as the preparation, are things you're going to need to think about. You have to think about those. For those of you who are applying for grant funding, those are things you need to think about at the beginning, because at least with NIH grants, you have to think about that now before you submit. And you also need to look at your repository options and see if they have time limits and things like that. You want to consider what will be accessible long-term. Okay, so like I said, there are a lot of different considerations. These aren't exactly linear. You can go back and think about these things at different points. If you aren't dealing with a grant agency or a journal who's telling you to do this, but you still want to participate in open science, great, awesome. You maybe have more leeway in when you have to think about these things. You aren't on your own though. You don't have to make all this up from scratch or anything. As part of this push from NIH, they put together a lot of resources around this. If you just type in NIH data management into a browser, you're going to find this page. And they did a bunch of webinars last year. If you wanted to find those, you can go to this About tab, and there's a section in there called Learning, and it's got links to the videos and the slide decks from the webinars last year. So it's all archived there. Here at UNL, we also have a page hosted by the libraries for research data management and sharing. As you would expect, we direct you to the NIH website, but we also have some resources from the Council on Government Relations that has done a bunch of stuff around the data sharing expectations as well. And I'll tell you who, potential places, potential resources for who to talk to on different topics. And maybe as not an involved things to look up, if you just want to look at what a data sharing template might look like, Research Compliance has you covered. So if you go to Research Compliance, there are research data and security templates and forms right here. They've got a data sharing template for you. And that's all I have.